Okay, so this is how to find washers, the area of washers around the y-axis. The first thing is to remember that the area of a washer is the outside radius squared minus the inside radius squared. And since we're going around the y-axis, the line furthest away from my y-axis is going to be my outside radius. And so this line right here is my outside radius. And that is x equals 3. Okay? Now, what we didn't realize is that to find the inside radius, we need to break this shape up into two separate parts. So I'm going to draw a line right here. And that's going to break my shape up into two pieces. I'm going to find the area of the washers comparing the outside radius to the inside radius for this section. And then below this dotted line, I'm going to find the area of the washers for this outside radius and minus this inside radius. Okay? So for this top section, my outside radius is x equals 3, and my inside radius, the line that was given, was y equals x plus 2. But if my outside radius is is x equals in terms of y, then my inside radius has to be the same. So that's why you take the y equals x plus 2 and you solve it for x. Oops. X equals y minus 2. Okay, so now they're both x equals in terms of y. So this outside radius is x equals 3. This inside radius up until this point right here is going to be x equals y minus 2. So then what we're going to do is the integral is, it's still the area of the disk, outside radius minus inside radius, so it's still pi r squared. So it's pi, and it's big R squared minus little r squared. So my big R squared is that outside radius, x equals 3. So it's going to be 3 squared minus this inside radius, which is y minus 2 squared. Okay? And it runs from this low y to this high y. So on the x-axis, this y coordinate here is 2 to this y coordinate, which is 4. So it goes from 2 to 4. Okay, so that's the first part of finding the area of the washers. Now the second part is going to be easier because it's going to be this lower section. So we're just going to add it. Okay, and it's still pi r squared of big radius minus little radius, but the big outside radius, I'm going to put a pi out here, the big outside radius is x equals 3. So, 3 squared minus the small outside radius is x equals 1 squared, and this runs from 1, oh I'm sorry, this was 3 to 5. 3 to 5. And this runs from 1 to 3. Okay, so not perfect. A couple mistakes there. But basically this gives you an outside disk which is pi r squared with a radius of 3, so that's a set size the whole time you move from 1 to 3, minus this inside disk, which has a set size of a radius of 1, so pi 1 squared the whole time as you move from 1 to 3. And that's what makes a washer, is a big disk minus a little disk. And it's this one that has more variation because the inside radius is not constant. Okay, so I'm going to send you that, see what you think, and I'll send you the next one. I think this was number 7, wasn't it? Yeah, this was number 7. Okay.